Okay, hi Bruce.
Hello.
So without further comments, the floor is yours, please.
Wonderful. Well, thank you very much. I do appreciate the opportunity of being able to present today. It's an honor to be able to speak to you and to talk to you about Postgres 14. Obviously, this has been a a challenging year for all of us, and it's nice to see the Postgres has continued in a good way during the pandemic. Um, I'm gonna show you sort of my highlights for Postgres 14, give you some of the backstory of some of the features, talk to you a little bit about the strategy of how I see the release, and then also talk about where I think things are going. So this release obviously is, as typical, has been around, been development for roughly a year at this point. We started in late June of 2020 with this particular release. This release is scheduled to appear in September, October of this year. And I'm pretty happy with the results. We weren't sure exactly how the pandemic was going to affect us, but in fact, it ended up being very positive. Again, my name is Bruce Momjian. I am one of the Postgres core team members, EDB employee. If you're interested in looking at my slides, they are right here at this URL, in addition to 58 other presentations, which is kind of surprising, but that I actually got the number recently. Again, if you find something you want to review back or you want to look at another presentation, I think there's 89 different videos of me giving presentations. So again, if you want to find a presentation and watch another video, feel free to do that. But today we're going to talk about Postgres 14, and I think you're going to find it quite interesting. What I did was I took the 8 major things that I think are in this release, and I want to go through those in detail. And kind of explain why I think they're important. Now, here at the bottom, there's a URL that has a link to the full release notes. So if you want to look through the entire release notes, and I recommend you do, that's the URL for you. One interesting aspect of this release is that typically, if you look back over the past 10 years, Postgres typically has between 170 and 190 features in every release. This release has 222. So that's roughly a 20% increase in the number of features, or actually 15%, 10%, and I think that's pretty significant to have a jump like that from roughly, we were averaging about 175 roughly the past couple of years, and it jumped to 222 or 224. I think is the current count, is pretty impressive. And I think I'm not sure if some of that is related to the pandemic and people being more available, working from home, or if it's increased interest, increased activity from a lot of the companies and users of Postgres. So I just don't know which one it is that's sort of driving that increase. It'll be very interesting to see if Postgres 15 has a similar count that's high, or whether it kind of goes back down to the 170, 180 range. Obviously, the pandemic has not affected our ability to put out the software. It has obviously adversely affected the events that we've been able to do. I usually do about 35 events a year, many of them in Russia. I have not done any events since February of last year. In person, the odd thing is I've still done the same number of online events. I am hopeful that maybe I'll be able to come to High Load in the fall. There may also be another Postgres conference or two maybe in Russia in the fall, and I would love to go to those if it's possible. So it looks like things are starting up, and we get to see each other again and do fun things together again, which is always true when I come to Russia. But anyway, the software hasn't slowed down. Yeah, the event in-person stuff has, but I think we're getting out of the woods. So here are the 8 items that I've picked as my sort of highlights for the release. Again, I've picked just a handful out of the 222 features that are available. I will say there is not a single big feature in this release. We have had releases where partitioning was the big feature, or logical replication was the big feature, or something that was sort of massive that you could say this is the big carrier. In this release, I can't say we have a big carrier. What we do have is a lot of improvements in what I want to call edge cases, edge use cases, things like doing massive insert updates into partition tables. There have been some vacuuming improvements, particularly one related to vacuuming of databases with a large number of objects, which had been a problem that somebody, I believe one of our Russian colleagues has reported, and I'm hoping this is going to fix that. I think it was somebody from Yandex actually reported the problem. And we have the ability to rewind with logical standbys. So there's some sort of edge case cleanups in there. And again, when you start to look at the release notes, you'll start to see that. But what I tried to pick here were the sort of either features you aren't going to see a lot, but are going to make a big impact. So things that might be a feature you don't even have to configure, it's just there. Or features you might not really think are important when you read them in the release notes, but actually I think are going to be pretty significant. And that's why I kind of picked this 8 that I think are going to be pretty strategic. There's also a lot of features out there that I'm not really clear how significant they're going to be. For example, we have a new compression method for toast storage. How significant is that going to be? I don't know. We're going to have to see. We have array subscripting capability for non-array data types like JSON. These are things I'm not really clear exactly what their impact's going to be. But these ones that I picked, I think, are going to be pretty interesting. And again, a lot of them you may not kind of catch when you read it, and that's why I wanted to kind of go over these. And I think these will have, to me, these will have sort of the widest impact in terms of usability and adoption for Postgres. And the first one is something that all databases have to deal with. It's really not a problem unique to Vacuum or unique to MVCC, but the problem really is keeping a Btree index lean, preventing bloat or preventing almost empty or a lot of empty pages from sort of bloating or increasing the size of a Btree index. This problem goes back into the 70s probably. And every year we seem to make small improvements of it. You may remember last year, thanks to code we got from Russians, we were able to add code that more efficiently handled duplicate entries in Btree indexes. So if you might remember that from Postgres 13, duplicate handling was greatly improved, and I think that's been pretty significant. This one is kind of an interesting one. I'm going to try and explain to you why it's important, and there's a philosophical kind of idea to this I think you'll appreciate. So this is typically the way a Btree index is laid out. You have an internal page at the top, and then you have leaf pages underneath it, and the leaf pages effectively point to the heap pages. So this is a standard way that Btree works. And if I look at it a little differently, what I've done is I've sort of split apart, the detail. And what I'm showing you here in the leaf page on the left is that the leaf page on the left is almost full, and it's got a couple dead rows in there, and that's the blue. You see the dead entries there. On the right, you see a page that is completely full. So you see it's completely pink. So what we have is we have a page that's completely full, but there's a couple dead row pointers in here. These are row pointers to either updated rows that have been expired, or they're basically row pointers of deleted rows that were marked as deleted back when somebody accessed them a while back, but they're still in the index. And previously to this, only the vacuum process, which you may be familiar with, would come along and remove these dead index entries and so forth. But the problem is if you needed to add a row to an index and it happened to need to be on the right-hand page, in previous versions of Postgres, there was no way to put the row there because vacuum was going to run sometime in the future. You know, you were performing an insert or you're performing an update, and you needed space on this right-hand page. So effectively what we would do we would split the page. So this page would become, the page on the right would become two pages, and half full roughly, or 2/3 full on one, 1/3 on the other. And the page would split, okay? And the problem there is that effectively you're splitting a page when you kind of could be more aggressive. So what Postgres 14 will do is when it sees a full page and needs to put a row in that page, instead of splitting the page, which is somewhat of a permanent operation because we don't merging Btree pages in a concurrent environment is very hard. What we actually do is we remove the dead row pointers and we free up space. So now I can do the insert. Okay, so I'm going back a slide. So instead of this, and we're trying to insert and the page is full, we're going to remove the dead pointers, the dead index entries, and we're going to make space, and now we can insert into it. Now you might think, okay, this is like a rare case. Why is this the number one item he's picked? And Peter Gagan, who sort of authored this concept, really had an interesting email discussion talking about it. And he said, people optimize for the common case. So when they're looking to gain performance, they're looking to optimize for what's a common problem, what's a common inefficiency. But he said, when we're looking at performance, we should also look at rare activities that have permanent consequences. So I'm going to kind of say that again. He was basically saying normally when people look at performance, they look at things that happen commonly. So if I have a loop and that loop is commonly run and it's inefficient, I can improve that. But what he's also saying, he says there are some rare cases that should also be optimized if those rare cases have permanent negative consequences. And in this case, and I think the reason we hadn't optimized this is the first time we've kind of done this optimization, is that the idea that a page is going to be full and have some dead row pointers in it like this one is fairly rare, right? But what he's saying is that if you split this page on the right, you create two pages, you're never going to get those pages back to one page again. For the life of that index, you're going to have two pages there, even if no new rows ever come into those two new pages, okay? Because it's very hard to merge Btree pages while there's concurrent operations going on. You typically have to reindex the column or recreate the index to fix that. So what he's saying is that this is a rare case, but every time this rare case happens, we're creating bloat in the table. And over time, this is why I didn't think people were really going to kind of get it unless I kind of went over it. Over time, these rare cases happen once a day, twice a day, 3 times a day. After a couple months, you potentially have a lot more bloat in the Btree index than you should. So again, I don't really understand I'm not positive what value this is going to be, but I think it's going to be pretty significant. The other good thing is there's nothing you need to do. It just, you install 14 and it's there, right? So that's, to me, that's a beautiful way to go. So that's why that was my number one. It philosophically, it handles a rare case that has permanent negative consequences. And second, it's automatically enabled by default. There's nothing you have to do. And that's why I named this one number one. I have a tendency to like the more complicated features anyway, but I think that's kind of cool. Number two, BRIN indexes improvements. You're probably aware of BRIN indexes. We've had them for many years. Thomas Vondra, I think, and Alvaro Herrera worked really hard to kind of get this in. And for this particular release, we've kind of taken BRIN indexes sort of to the next level, I would say. So, as you may know, BRIN indexes up until Postgres 14 effectively took a range of pages or a range of bytes in the table, maybe a megabyte, and it had a min max value for that megabyte. And then when you scan the index, it would tell you, the minimum and maximum it existed in that 1 megabyte range, and if your value was in that between the min and max, you had to scan that range. And if it wasn't, you could skip it and go to the next one. So again, for really big tables, this was very useful. However, there was a problem, and the problem was that the min-max indexes only had one min and max, right? So you couldn't, you just had a min and max. You didn't have anything like more granular. So in Postgres 14, you can effectively have multiple min and max ranges. So for example, you may say this one megabyte range has values between 10 and 0 and 10 and 30 and 40, right? So now instead of having just two values of min and max, you can have multiple min and max ranges within a single blob, 1 megabyte chunk. So there are certain values that makes a lot of sense for. Not everyone, but I think there are definitely use cases where this min and max will be beneficial. So again, you can control how many of these min maxes you want per range. But again, if you've got a complex layout, you might find that having multiple min maxes is valuable. The second feature, which I think is really a game changer, is that typically BRIN indexes were only good for data that had some kind of locality. So data that had some, particularly, it was really good for time series data, where you're always adding to the end of the table. So you had, typically you had, certain months at one part of the table and maybe a certain month at another. You could still move stuff around, but you had to have some kind of locality typically for min-max to make sense. In this change now, we can actually use what's called a Bloom filter. So the whole requirement of locality is kind of gone. You end up with basically creating a huge Boolean array, and you hash your constant. You don't sort of have to do min max anymore. You hash your constant, and your constant represents a bit in that big array, and you just basically mark that bit as present or not present. So you can basically say, I'm looking for a certain value. I hash my value. I look at the bitmap. Is there a 1 there or not? If there's a 1 there, it might be in the range. If there's a 0 there, it's not in the range. That's the way typically, it's a lossy index. You don't know for sure it's in, but if it says it isn't there, you can be sure it isn't there. Same thing with the way min-max works. So again, I think this is taking BRIN to a completely different level. Because the locality requirement really isn't there anymore. Now you can do it with distinct values rather than ranges, which only, again, worked for certain use cases. So again, I'll be really interested to see what type of data use we end up using with these Bloom filters. But this all work done by Thomas Vondra. I think it's really, really interesting, particularly the Bloom filter one, which I think takes BRIN indexes to another level. Number 3, this is work by Andres Frud. And again, this is one of those, like, you're going to squint and say, I don't get this. I had trouble understanding it. But basically, if you've been around Postgres for a long time and heard some complaints over time, and I know we've had complaints from Russia, particularly, that Postgres didn't perform well with very high connection counts. So if you had 100 connections, 400 connections, Postgres ran fine. But if you had thousands of connections, 5,000 connections, 10,000 connections, Postgres, it didn't perform well, and particularly didn't perform well as other competing relational databases. The reason for that, we've been sort of chipping away at this problem for a while, but this is we did a little bit in 13 related to this, but 14 is I think going to be the big one, and the big holding or the big slowdown we had seen in that 5,000 connection workload is something called snapshot acquisition or snapshot generation. So this slide here is from my MVCC talk, and effectively, every time you start a transaction, you have to generate something called a snapshot. And that snapshot says which rows you can see and which rows you can't see. Again, very, very typical for MVCC. And when you had 100 connections or 400 connections, that snapshot could be computed very easily. But when you had thousands of connections, particularly thousands of idle connections, so you may have only 50 active connections, but you may have thousands of idle connections. Imagine. When Postgres would sort of look through all the connections to figure out which ones are active, which ones weren't, it would slow down Postgres because it had to look through all thousands of these connections. So what Andres did is he basically restructured the way that we track and way that we compute these snapshots in a very clever way, which allows you to quickly acquire or quickly compute the snapshot for a new transaction without being slowed down by a lot of inactive transactions or inactive sessions that may just be sitting idle. So again, I think this is interesting. It happens automatically. Again, there's nothing you need to do, but just like with the Btree expansion, I think this is going to allow Postgres to work in more high connection environments with better performance than I think we had in the past. Now, where this probably is not going to help, if you have 1,000 active connections, and very few inactive ones, is probably not going to help you. Where I think the major help is going to be is when you have a lot of inactive connections and being able to compute a snapshot without being slowed down by having to look at thousands of other idle connections. I think that's going to be the real win. And I've seen Andres had some pretty interesting calculations of the speed up of that. Because again, you don't know. Sometimes your system's very busy, sometimes it's idle. You want the system to sort of adjust to that automatically, and I think you're going to get that here. So I'm excited about that one. This one has a whole story on its own. I'm not really sure where to start. I guess I'll start. I was in Korea probably 8 years ago at an EDB customer. And the customer explained that they were using pgstat statements, which everyone loves, right? And he said, I'm using pgstat statements. As you know, pgstat statements will take a query, it'll remove the constants, it'll generate a hash, and then it will compute for that particular hash how long the query takes, and then you can get aggregate stats on, well, how often did I run this type of query irregardless of the constants? How long did it take? How many times did I run it? What was the average runtime? So forth. But he said, I'd like to take the information from pgstat statements, and I'd like to be able to look at a current query. So this is really interesting. He said, he said, if I look at pgstat statements, it tells me a certain query takes 5 minutes. I should be able to look at my current queries and look up, okay, for this query that's in pgstat activity, what is the average runtime as reported by pgstat statements, right? You want to be able to get that query, you want to be able to take the query ID of a running query, get the hash of that, and compare it to pgstat statements. And again, this sat in my inbox or in my sort of to-do wish list for like 7 years. And fortunately, we got it in Postgres 14. It was not easy. It's actually, you would think you would think it should be real easy because how hard could it be? We already have the code. It's already in pgstat statements. Why can't we just move it over? But Julian Rahaud, who actually is French, but he lives in Singapore now. He worked really hard to get this code out of pgstat statements and into the core server so that you could see it in pgstat activity and you could also see it in the server logs. The reason it was complicated is because the computation of this hash is fairly expensive. So I think we saw something like a 2% overhead of computing this hash, which I was kind of high, but that's what it is. So we couldn't enable it by default, but at the same time, everyone was using pgstat statements, so we didn't want to require everyone using pgstat statements to somehow also configure the server to compute the query ID. I actually committed Julian's code, which did it that way. And about 2 weeks before feature freeze, people said, "Oh, I'm using pgstat statements. I don't want to go and modify PostgreSQL." And I'm like, how hard can that be? Like, you already installed pgstat statements. I know, but I'm so used to it. And anyway, we had a big discussion. Alvaro Herrera ended up being the committer of this because I kind of it was so close to feature freeze that I passed it to Alvaro because I thought he would be better at fixing it and making sure it worked because he uses pgstat statements a lot, so he could like test it and make sure everyone was happy. Because it was the weird thing, like I got Julian's code in, and then 2 weeks before, everyone's like, no, I don't want to have to modify PostgreSQL to deal with pgstat statements. I want it just to work on its own. So the end result was that we have a new server variable called compute query ID, which you can see here in red, but the default is auto. And auto means that an extension can turn on the query ID computation, which is kind of unusual for an extension to be controlling the server, but to prevent any kind of need for modification of the Postgres comp, you had to have a way for an extension to enable it. So I thought that was kind of odd. But anyway, Julian was good with it. Alvaro Herrera was good with it. So it's in. But again, this was a weird case where the actual code was easy. It was getting everyone to agree on what the API should be with the interaction with pgstat statements that was so hard. And also we have to allow for extensions to compute their own query ID. If they want to, you can have an extension use its own algorithm for query ID as well. So again, it got really complicated, but I'm really happy that we got it in. Julian, I'm sure is happy, and I'm very, very pleased. And I think this is a big one because, as I explained from the Korean example, you now can tie pgstat statements to pgstat activity and the server log, and now have a one place, or what we call a global query ID computation that you can use to sort of reference the same query types without constants in all of these places at once. So I think this is really opening a whole new way of doing monitoring. To enable it, I used alter system here to turn on compute query ID to on instead of auto. I did set logline prefix And what I did is I added a new letter %q, which will output the query hash. And then I also said logmin duration statement, as you can see here at the bottom, the query ID appears in PG stat activity, and it also appears in the server log. So again, I think this is really a big thing. You might not sort of see it that way, but it opens up a completely new way of getting analysis of queries that I'm surprised it took us so long, but we got here, so I'm happy. This is another one, number 5, which is one that you would think we would have had forever, but we kept thinking, how do we do this cleanly? How do we do this without like causing weird behavior? But we ended up just, I guess, by the time we came to 14, we're like, oh, we're just going to do it. So the new setting is idle session timeout. You set idle session timeout to 1. If you wait 2 seconds and then you type select 1, okay, it basically disconnects you. So between this command and this command was 2 seconds. And by the time this was issued, I had already been disconnected. So this, again, kind of related to what I talked about earlier with the snapshot computation. This gives you another way of trimming or removing sessions that are not active. We think it's awkward that you're just thrown out, like you just get this error, but there's really nothing else we can do, right? You've disconnected. We've disconnected you. You no longer have a connection to the database, and you get an error. So not much we could do there. It is what it is. But it's something you would have thought that we could have done a long time ago. But I think there was some sense that just disconnecting people is rude or disruptive. But there's some people clearly who want this, and I think I'm very excited we got it. Number 6, this is a really interesting one. I'm not even sure how to kind of explain this, but Stephen Frost has been doing a lot of work with what used to be called default roles, but will now be called in Postgres 14 predefined roles. So when we used to call them default, people would think, oh, that's like I default to something, but in fact they aren't really that. They're just predefined. There's nothing really default about them. So those were renamed in Postgres 14. So you're going to see the term predefined roles a lot more. And 2 new predefined roles, which I think are really powerful, is a role that allows you to read all data and a role that allows you to write all data. So in this example here, I'm creating user 1, user 2. User 1 is a standard user. User 2 is in a group called PG read all data. That's all we did with that. That's the only difference between the 2 users. Then we create a table with the value 100. We connect as user 1. We do select, and not surprisingly, we can't see it. Because I was Postgres as I created the user, because I was a super user. Now, obviously, as user 1, I can't read from that table. I haven't been granted select permission on that table. Okay. But then I switched to user 2. And the big takeaway here is that when I select from user 2 can see the data, even though they haven't been granted anything different than user 1. All right. And of course, the same happens with write, with the PG write all data. These are very powerful roles. Don't use them, capriciously. But for example, if you wanted to create a backup user which could read all of the data, that kind of thing, this would be a very natural role to give that person, and they couldn't write any of the data, but they could read all of it. So again, I think this is kind of very powerful, and I'm glad to have this new capability, because I think it makes management a lot easier. Number 7 is kind of a catch-all. There are 3 optimizer improvements I think are important. The first one is the use of a hash lookup for an in clause with many constants. We've all seen queries where, whether they're user created or computer generated, where they say, where column in parenthesis, and the numbers just go wrap around the screen. And you're like, whoa, 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 how does that happen? Well, a lot of, auto-generated code is that way. Sometimes there are legitimate reasons to have that many constants instead of having them in a separate table or something. And previously, the way we would do the in evaluation is we would literally check every single value. Is it equal to the first value? No. Is it equal to the second value? No. And we just walk through them. Now, that works if there's a small number. But if there's a large number, then being able to use a hash, do a hash lookup and say, okay, is this in any of this list? And I just hash it, and I can see right away if the value's there or not. So again, I think that's it's not a common use case, but it's a use case that people expect to work fast. And sometimes it didn't if there was a lot of constants. And I think that's a really nice change. The last two that are mostly Thomas Vondra from Prague, and they're related to extended statistics. Now, you might not be familiar with extended statistics. Extended statistics are. I was so happy when Tomas did this a couple of years ago, because there were so many cases where the optimizer was not able to get good statistics, particularly when there was some interaction between, like, say, 2 columns or 3 columns. We couldn't kind of get a good analysis of how the two were related to each other. And I estimated probably 90% of poor plans were probably caused by our inability to have these extended statistics. And Tomas was able to get these a couple of years ago. I think it went a long way. So now when people have problem queries, they have the tool of extended statistics, particularly if they've got 2 columns that are correlated. Now they can create extended statistics between the 2 columns and get much better statistics for the optimizer to use. But there was a limitation, particularly they could not be used for certain types of OR clauses until Postgres 14, and they couldn't be used for expressions. Tomas in Postgres 14 has fixed both of those, so now you can use extended statistics for OR clauses and expressions, which I think is taking it another level. Of sort of giving the optimizer that kind of information needs to get good estimates. And once it has good estimates, it's pretty good at generating good plans. And finally, this one is really kind of going to be a surprise. If you look at the release notes, this item isn't even like listed at the top of its section. It's like somewhere down in the middle of the section that relates to foreign tables and general performance. In fact, it looks like it's number 5 in a list of 10, right? So why am I picking an item that I wrote? I did the release notes. Why would I pick an item that I put so far down on the list? Well, this is one of those sort of long-term features that I think is very significant. As you may know, Postgres runs great on single machine. It runs great if you get a bigger machine. It runs great in a primary standby kind of setup. But a lot of workloads we're finding, if they have very high write volume, they can't exist on a single machine. It's just too big. It's too much data. Think petabytes of data, for example. And Postgres really, at least Postgres community, has not had a great answer for sort of multi-server or sharded workloads. Now, I know Citus has worked on that. Greenplum has a version, certainly, that does it very well. But community Postgres really didn't. And what I see this item as is a pretty big step in the direction of allowing us to improve our ability to shard data across multiple servers where, maybe 10% of your data is on the first server and 10% of your data is on the second server. Maybe you have 10 servers. And the ability for queries to be sent to a coordinator, as I'm showing you in the green triangle here, and the coordinator to send the queries down to the shards. The big change is that now you can send these queries in parallel to the shards. So now we can effectively support things like parallel aggregates, parallel sequential scans on these shards. I'm waiting for somebody to do some performance benchmarks of exactly what is possible if you take 10 machines and you sort of put them together and use partitioning and use all the push down capability we've been adding for years to foreign data wrappers to sort of see what capabilities. Now, because we don't have a global transaction manager or a global snapshot manager, this is not going to be very useful for write-heavy parallelism because you can't really do transactions across them real easy. You can with prepared transactions, but it's a little awkward. But I think for data analysis, I think this is going to be pretty big, and I'm curious to see what people are going to be able to do with this feature because it's only been in a couple months. But once it gets into production, I'm really excited. So that's why this is sort of my closer. I don't know what value it's going to have right away, but it's a big step on the stages that we really started maybe 5 years ago of improving the way partitioning works, improving the way partitioning and particularly foreign data wrappers work to allow for this parallelism now. Really starts to get Postgres into sort of a parallel server kind of capability, at least for read-only type of queries. So I think this is really interesting. I'm excited to see where it goes. That there's still a little more work to do, but I'm super excited. And this was done, I believe, mostly by the Japanese. I know Asan Hadi did a lot of sort of coordination with it. But a lot of it, I think, was Japanese team who did most of this work, and very impressive, very impressive. So that does conclude what I wanted to talk about. Again, I only picked 8 topics. There are 220 or 215 more in the release notes, and I'm sure you'll find something there to be excited about. But I just wanted to give you the things that I was excited about, so you kind of have a feeling of some of the stuff you might miss. And why I think they're important. Great, thank you.
Thank you, Bruce.
Okay.
That was exciting as usual. And we have a couple of questions, actually. So one of the questions is very traditional. Are there any features in this version which almost done to the release, which you're excited about, but which didn't? So is there something you are missing in this version?
Yeah, there was one. I'm trying to remember what it was though. Yeah, there was one I was kind of bugging Heikki about. I was hoping he'd pick it up, and he didn't. And I hate to even mention it because I'm gonna probably embarrass somebody if I do. I probably embarrassed Heikki by even saying I bugged him about it. But yeah, there was one feature, but I can't remember what it was. I guess it wasn't. It must not have been that significant if I'm not like super upset about it. But yeah, the one that I really wanted was the query ID, because that one for me had been laying around like forever. It just couldn't get. I think it went back to 2018 or 2000. It was at least 2 years old. Julian had been playing with this thing, and we just couldn't get it kind of over the finish line. And I don't know. It just bothered me that it was so close. So fortunately, we got that one in. I don't remember what the other one was, but if I remember, I'll let you know. I don't remember what exactly, but it was one that Heikki had worked on.
Yeah, thank you. And we have another question, which is like very laconic. How about absurd?
Right. So I know that they're trying to get merge back into the code. Merge is a SQL standard. It isn't as useful as the on conflict clause, but I think merge has a good possibility of getting it because there are some advantages to merge, and I think we did have some people working on that, but I haven't actually seen what I haven't seen any work in the past couple months, and hopefully in 15. But upsert itself is a word I don't think is going to go anywhere because I don't think there's a lot of value to that over having the two. If we have merge and on conflict, that's probably all we need.
Yeah, thank you. Another question, which I don't know, it's deleted now. I don't know if I need to ask that again, but yeah, the question was like, do we need to refresh materialized view in 14th? But I don't know if it's like.
Yeah, so that's a good one. That patch is still being worked on. The refresh materialized view. We have refresh materialized view, but unfortunately, it rebuilds the whole thing, right? So it rebuilds it.
The person who asked that corrected the question actually.
Right. So they want more granular, granular refresh, and I think the Japanese had a patch for that, but it didn't get into 14. I remember seeing it, and I hoped it would get in, but for some reason it didn't, and I was kind of disappointed by that. That's one I was disappointed by. I thought that was kind of cool if they could do that. But it's still out there. The patch is still out there. It's still getting. What I actually ended up doing because I'm not traveling as much. I ended up literally going out and looking at the commit fest and looking at what commit fest entries have been out there forever, and that's how I got on Query ID. I was like, oh, this thing has somebody asked me for it 7 years ago, right? And B, we got a patch, but we just can't get it because every time somebody tried to play with it, they would get stuck with, oh, well, what's the syntax and how do we make it auto work with PGStat statements, and PGStat statements people don't want to do anything more. And it wasn't a technical problem. It was just a confusion problem, I guess, or I don't know what it was. But eventually everyone was happy. So I thought that was good.
Yeah, and at the same time, many external tools already have their own sort of query ID, which is like even synchronized between some of them. So basically, it's like very ridiculous that Postgres itself doesn't have query ID.
Yeah, and then some people are saying, well, they don't like the way Postgres does it, so like they want to do it some other way, and I'm like, okay, but let's just decide. Like, let's just, I don't care what we decide. Let's just decide something, right? So that was kind of my sort of way of looking at it. Let's just decide something and get something in the code. We already have something that works, so let's use that.
Yeah. Great. So, do we have any more questions? If someone's just typing, like wave me that I'm typing. Otherwise, oh. Yeah, that's just not a question. It's just thank you for the great presentation. Great. So then we are always done. We will invite Bruce to the Slack channel with Q&A, just in case if someone forget to ask something. Thank you, Bruce. That's a great talk to finish the great thing.
Thank you.
Our elephant is just 25 years old yesterday, and
that's right.
Yeah, that's right, and it would be actually quite better if we could celebrate this in person in St. Petersburg like 5 years ago.
Exactly what I was thinking. Yeah, somebody yesterday reminded me. They said, didn't you do the 20th list 5 years ago? I'm like, yes, I did, in St. Petersburg. Absolutely. Yep.
Yeah.
With the big cake, I remember.
Yeah, hopefully next year we will do this. Great. Anyway, thank you, Bruce, and thanks for coming. Thanks for great talk. We'll move to the closing ceremony.
My pleasure. Thank you, folks. Bye-bye.
Thank you.